So here's a question that puts our knowledge of quadratics to somewhat practical use to see whether a coach will fit into this tunnel, which is modelled as a quadratic curve. But first of all, we've got to find an equation for the curve BAC, which is the quadratic, given that the base of the tunnel is 6 metres and the height is 5. Well, if the base is 6 metres, we've got point A, which must be -3, and point B, which must be +3. These are crossing points of the x-axis, so these must be roots. So our equation must be in the form y is equal to x minus 3, x plus 3, which if you multiply it out, does give us a quadratic. They are the factors of that quadratic because we actually know the roots must be here and here, +3 minus 3. The thing we don't know is that when x is equal to 0, we don't know the height c. So in a way, we must put a constant in here, let's call it k, which will determine how high the curve goes. So how do we transfer the knowledge that the height of the curve is 5 to our equation here? Well, we can actually say that when x equals 0, y must be equal to 5. So when x is equal to 0, I get -3 multiplied by +3 multiplied by k, and that must be equal to 5. So therefore, k is equal to -5 over 9. So our equation becomes, and we can pop these two factors together as the difference of two squares, so I get that x minus 9 squared multiplied by our value of k that we found to be -5 over 9. And I would suggest that was a perfectly good answer to part A. But bear in mind the limits of this curve must be that x cannot go beyond 3 and cannot go below -3. So let's have a look at part B. We're asked whether a coach of height 4.1 metres and a width of 2.4 will fit into the tunnel. So let's draw a diagram of the problem. So there's a fairly crude diagram of the coach. So this is 4.1 metres and the width is 2.4. So if the width is 2.4, this is -1.2 and this is +1.2, either side of our 0 point, which is here. So if I substitute a value of x is equal to 1.2 into the red line curve, I can find the height of the curve at that point and see whether it's above or below 4.1 metres, and therefore that will determine whether the coach can fit in or not. So I'm now going to sub x is equal to 1.2 into our curve here. And what do we get? We get that y is equal to -5 over 9 multiplied by 1.2 minus 9 squared. And if you put that into a calculator, I get the fact that y turns out to be 4.2. So if at a width of 1.2, which is the coach's width, the height of the curve is 4.2. So yes. So therefore the coach will fit in. So in part C, we're asked to suggest why the model might not work. Well, of course, the biggest restriction is that the tunnel might not be uniform. So that's our first one. And there are many more reasons. The road on which the coach goes might not be entirely flat. So let's write that down. Or it might be cambered, or there might be a light dangling from the ceiling, or one of the bricks in the tunnel might not might just stick out. So there are many reasons, I'm sure you can think of others, why this may not work. But there you are. There's the maths anyway. Hope that was okay.